Hello everybody, Mr. Uminski here, starting lesson 1.5, greatest common factor, which I am sure you have done before, usually by listing out all the factors and finding it, but we're going to actually try show you a different way here that you may find a little easier in terms of finding greatest common factor. So just kind of like as a reminder, right? The greatest common factor, we know when we have like a number like 12 and 16, when we break these numbers down, right, we know that there are factors they have in common, like 4. Right? 4 times 3 is 12 and 4 times 4 is 16. They both share that. That's a common factor, a factor they have in common. Also 2. We know 2 times 6 and 2 times 8 get 12 and 16 respectively, and they are common factors, right? Number that would not be common is like 6, right? 6 times 2 is 12, but nothing goes into 16, so that's not a common factor. So common factors are these. The greatest common factor is obviously the biggest factor they both share, and in the case of 12 and 16, I think we'll find that the answer is 4. Right? And so the way that this usually has been presented and done before, as you go out and do these problems, is by listing factors, right? And so here it says find the GCF, the greatest common factor of 24 and 40. Well, generally in the past I would say that when this is done, generally what you've done in the past is you said, all right, here's 24. What are all the factors of 24? Well, it's 1 times 24, so 1 and 24 work. 2 and 12 work. 3 and 8 work. And 4 and 6 work, right? So these are all the different ways you can get 24. These are all the factors, right, that can get to 24. And then 40, you do something similar. You come over here, you do 1 and 40. There's two factors, 1 times 40, right? 2 times 20, right? Nothing in 3. 4 times 10 is a factor. 5 times 8 is a factor. And nothing in the 6s and 7s. So here are all the factors for 40. 1 and 40, 2 and 20. And so when we're finding greatest common factor, what we see is that 8 is the biggest number that shared in these two factors. So the GCF of 24 and 40 is 8. Now that's all well and good, and that definitely works. But I would argue, especially when you get to a greatest common factor involving 3 numbers, or if the numbers are a little bit more difficult than 24 and 40, generally a mistake that I always made when I was in middle school was that I would leave off a factor pair somewhere, and I would miss it. So I'm going to show you another way that may help you in not missing a factor pair as we go along. Okay? And so we're going to use 12 and 56 here, and I'm going to show you how I would do this. And maybe it'll be a way that helps you. Now it says up here prime factorization. We're not using prime factorization. I'm not even going to show that to you because I think that's way confusing. If you really want to see what it looks like, you can look in your textbook. It will show you how to do it. But I am going to do something that is called the cake method. Alright? And the cake method is a way in which you can find the greatest common factor in what I think is an easier way. 12 and 56. And also, when we do least common multiple tomorrow, or I guess the figurative tomorrow, Monday, you'll also see that the cake method plays into a factor there. So the cake method is we start by writing the two numbers we're trying to find the greatest common factor of. And it can be 3 numbers too. And I think we'll get to an example of that in a little bit. But for now, we have 12 and 56 here. They are the numbers that we're trying to find the GCF of. Now, when I do cake method, what I am aiming to do is I am trying to find out and take out a number that is divisible into both numbers. So 12 and 56 are both divisible by 2. So I'm going to write that on the outside here. 12 divided by 2 is 6. 56 divided by 2 is 28. Right? And then I'm going to add a layer of cake here because there's still a number that is divisible in both 6 and 28, which is, again, 2. 6 divided by 2 is 3. And 28 divided by 2 is 14. Notice now there is nothing else that can go into both 3 and 14. So, we are going to look at the 3 and the 14, see that there's nothing else that can go into it, and that's it. We can't add another layer of cake. Now, you can see why it's called cake method, because it kind of looks like we have layers of cake here. And now here we kind of have like the icing, right? To find the GCF, oops, I am not writing really well there. GCF of 12 and 56, we just multiply the two numbers that are in the icing here. 2 times 2. 2 times 2 is 4. So the GCF of 12 and 56 is 4. Okay? And so that is essentially what cake method does. It's just a way we can break things down. And look here, if I was doing 12 and 56, I'd have to do 1 and 12, 2 and 6, 4 and 3, and then I have to try and figure out all the factors of 56. 1 and 56, 2 and 28, 4 and what? 16, 14, 4 and 14. Like, and you see, even me, I have to think about it. It's 4 and 14, and then I kind of keep going, 7 and 8, etc., etc. I have to think about that. Here, I didn't have to think so hard. All I had to do was divide by 2 a couple times, and boom. Multiply these two numbers, and I get my cake. So I'm going to do another example with this, so you have a chance to see what that looks like. Right? So here it is again. I'll use blue this time, right? 40 and 48, right? GCF. Now again, I'm going to use this cake method here. I'm just going to blow it out here. 40 and 48, I can see 4 goes into both. 40 divided by 4 is 10. 48 divided by 4 is 12. They're still even. I can still see another layer of cake I can do here, right? Now, the beauty of this is if you didn't see the 4 and you saw the 2 first, you could have just went right ahead and did the 2, and you still would wind up at the same answer in the end. 10 and 12, 2 goes into both. Well, that's a terrible 2. 10 divided by 2 is 5. 12 divided by 2 is 6. And now, 5 and 6, there's nothing else I can do. That's the final layer of our cake. But to find the GCF again, I still have to multiply by the 2 numbers out in the icing. So GCF is 4 times 2. And 4 times 2 is 8. The GCF of 40 and 48 is 8. Okay? So, let's see. Alright, so, example 4 here, trying to reverse this a little bit. Which pair of numbers has a GCF of 15? Right? And so, I can jump out over here real quick, and I can start figuring this out. Okay? We have 10 and 15, right? 10 and 15 is where we're starting. And here we go. I'm going to take 5 away from both. I get 2 and 3. GCF here is 5. So it cannot be A, right? Because we're looking for 15. All right, 30 and 60. First thing that I see here is 10. They both end in 0, so I see 3 and 6. And 3 and 6 also has 3, right? So 3 divided by 3 is 1. 6 divided by 3 is 2. If I multiply over here, 10 times 3 is 30. That's the GCF for this one, so it can't be B. Now I go to 21 and 45. Now that's a little bit, this is a tough one at first here. Let's take it. But we see that 21 and 45 is 3. 7 and 15. Nothing else goes into that, so 3 is not it. So hopefully it's D here. Let's do D. 45 and 75. I'm going to, first thing, they both end in 5, so I see a 5 here, which means I have, let's see, 9. And over here I have 15. Alright, so 9 and 15 I see has another factor, which is 3. Right, 9 divided by 3 is 3. 15 divided by 3 is 5. And here in my icing, I have it. 5 times 3 is 15. So that is your greatest common factor, D. Yeah, terrible draw in there, but you can see. Okay, so there's your greatest common factors. Right? You see how in each of these cake methods, right, it's just a matter of dividing out until you get divide no more. Alright, one more example I think here, and that is an example 5. Oh, that's not what I wanted. Example 5, there it is. Alright, so here's what I was talking about. I was talking about an example earlier. Oh, what happens when you get to 3, and then you have to start doing that, and that can be difficult too. You are filling piñatas for your sister's birthday. The list shows the gifts you're putting in the piñatas. You want to find out the identical groups of gifts in each piñata with no gifts left over. What is the greatest number of piñatas you can make? And this is really saying, right, I want to do greatest common factor here, right, because greatest common factor, right, GCF, is saying, what is the biggest number that goes into all of these numbers over here? And that would tell me how many of each of these gifts I could put into each of the piñatas and still have nothing left over. So the greatest number of piñatas I can have. Right? So I can do the same thing I was doing before, but now with 3 numbers. 18, 24, and 42. Right? And now I draw my first layer of cake. And in this cake, I gotta look, what goes into 18, 24, and 42? Well, 2 is definitely a number. That goes into all. They're all even. So that's the first thing that jumped out at me. So that's what I went with. 9, 12, and 21. Right? And so here, I see right away that 3 goes into all of these as well. 9 divided by 3 is 3. 12 divided by 3 is 4. And 21 divided by 3 is 7. Now, is there anything that goes into 3, 4, and 7? No. There's nothing else. So right here, here's my icing. I do 2 times 3. 2 times 3 is 6. And my greatest common factor here is 6. Now, could you list out all the factors of 18, 24, and 42 and come up with that as well? You could. And if that's the way you want to do it, because that's the way you're used to, you can. But hopefully you're seeing some value in the cake method here as well. Alright. So, that's kind of where we are at. I'm going to go over one more time here. I'm going to go use this one right here. I'm going to go over one more of these to kind of show you exactly where, and just review one last time, cake method, right? So I'm going to look at number 4. I'm going to look at the hardest one here, right? So, cake method. You list out the numbers you're trying to find the GCF of. In this case, 12, 54, and 84. Draw the first layer of cake here, and you're looking for a number that divides into all three, which in this case, again, because they're all even, I'm going with 2. 12 divided by 2 is 6. 54 divided by 2 is 27. And 84 divided by 2 is 42. Now, this one's a tougher one. Is there a number that goes into both 6, 27, and 42? And indeed there is, which is 3. Right? 3 goes into both. So, 6 divided by 3 is 2. 27 divided by 3 is 9. And 42 divided by 3 is... Where was I with that? 42 divided by 3 is 13. Sorry about that. Right? No, 13? 30? No. 14. Sorry. 14. It is 14. So, 42 divided by 3 is 14. So, now I look at 2, 9, and 14. Is there a number that goes into both 2, 9, and 14? No, not all 3. There's a number that goes into 2 and 14, but unless it's all 3 for GCF, that's all that matters. So, here we go. 2 and 3 do. So, I do 2 times 3. I go to my icing to find out what the GCF is, in which case that doesn't look right. That's better. 2 times 3 is 6, and that is the GCF. So, the GCF of 12, 56, and 84 is 6. Alright, hope that helps. Hope that gives you a good start for GCF. You can start working on the IXL video, or problems rather, and you're good to go from there. Alright, have a great afternoon and a great weekend, and I'll talk to you soon.